All right. Well, I'd like to welcome everyone to our webinar today, and we appreciate you all joining for this lunch and learn. I'm Claire Jantz. I am now an affiliate scholar at the Center for Land Use and Sustainability, and I currently or recently transitioned to the Department of Conservation and Natural Resources here in Pennsylvania, but still actively engaged in the CLUS. And this presentation is based on a project that we did that was funded by the William Penn Foundation to kind of look at carbon dynamics and land use in the Delaware River Basin. Our key questions that we're addressing are here. We did a greenhouse gas inventory for the Delaware River Basin in a couple of different ways. We looked specifically at forests and farmlands and how they offset current carbon emissions. And we also looked at a couple of different management strategies to see how they can, or how and if they can do more with different management strategies. And then we also explored some different scenarios for how other land use choices might influence net greenhouse gas emissions. So let me introduce our co-authors. So Franklin, if you want to pop it back to the first slide just to get everybody's names up there. I was kind of the main cat herder on this project, and I want to make sure to introduce Franklin Egan, who's a collaborator from Clear Climate Strategies. Franklin is actually going to lead the presentation today. Nick Pevsner from UPenn was also a participant, and then we have Alfonso Yanez Morillo, who is here with us today as well. And I hope that that Nick will join us today. The way we'll run this is I'll turn it over to Franklin here in a couple minutes, and he'll kind of take the lead on the presentation. We're going to ask everyone to keep their microphones muted for the time being, and we'll take questions at the end. And if you want to pop in questions into the chat during the presentation as you think of them, feel free to do that. Holly and I are going to be moderating the chat, and then we'll sort of look at those questions in the chat and take other questions at the end. So without further ado, I'll hand it over to Franklin to get us started.
Great, thanks so much, Claire, and thanks everyone for joining us today. Yeah, as Claire mentioned, this was a project supported by the William Penn Foundation, and I know that many of the folks on this call are involved with the Delaware River Watershed Initiative. Historically, William Penn and others have helped to guide a lot of research and practice around conservation in the watershed for water quality and other purposes. And William Penn was trying to get a handle, a sense for how those water quality initiatives might be able to better link up with climate and climate mitigation questions. And so that kind of guided this project in us trying to understand what the Delaware River Basin's role is in contributing to climate change, and then really drilling down into detail into understanding how forests and farmlands could contribute or do contribute to removals and mitigation of climate change. So that's what our team worked on, and I'm happy to try and share some of those results and hopefully get into discussion of that with you all today. Okay, so of course, we're talking about climate change. We're talking about this, massive global problem. And our role with this project was to try and understand better what is the role of this watershed, the Delaware River Basin, in contributing to this problem, and how might it be part of the solution. And so to do that, the first step is always to run through an exercise called a greenhouse gas inventory, really taking a careful stock of where greenhouse gases and climate change causing pollution is coming from in a region. And you're looking at basically a story of three primary pollutants, greenhouse gases, and then surveying where they come from in a community, in a region. And so you have to take stock of carbon dioxide emissions coming from fossil fuel combustion and land clearing, land use change. You have to take a look at methane, which primarily comes from ruminant livestock like beef and dairy cows, as well as landfills. Can come from fossil fuel extraction, although there's not a whole lot of that going on in this watershed. And then also nitrous oxide pollution, which primarily comes from manure and fertilizer applications and fossil fuel combustions. And so for the purpose of having kind of a clean system of accounting, it can be helpful to try and combine these different pollutants into one index to keep tabs on. And here we have to think about a concept called the global warming potential of these greenhouse gases, which is basically their lifetime contribution to warming and trapping heat in the atmosphere. And scientists have developed a series of indexes where we can kind of compare them all and get them all on a common unit of measurement called a carbon dioxide equivalent. And so in this system, carbon dioxide, which is the most abundant greenhouse gas by quantity, can be compared to other pollutants like methane, which would have 28 times the warming potential, and then nitrous oxide, which has very large global warming potential of 264 times that of carbon dioxide. So this is just a helpful way to kind of put things on a common unit of measurement, but there are some important nuances there, and I'll come back to that later in the presentation. We try and think about, particularly with agriculture, managing methane and nitrous oxide separately. So we commonly report greenhouse gas inventories and greenhouse gas pollution in units of carbon dioxide equivalents, typically talking about metric tons. And so just to kind of put that into some common, maybe a little bit more approachable units, 1 ton of carbon dioxide equivalents is about the pollution generated by driving a typical US passenger car 2,500 miles. It's generating 2,300 kilowatt hours of electricity on the average US grid. And it's the carbon sequestration of about 1.2 acres of US forest in 1 year. So how many of these tons of carbon dioxide equivalents does the Delaware River watershed, Delaware River Basin contribute? And so we did a lot of math to estimate that, and this is what we came up with. So here's our greenhouse gas inventory for this basin, and I'm not sure if folks on the call may have ever contributed to a local climate action plan for their municipality, or maybe read one of these reports. But this greenhouse gas inventory looks like the inventory you see from most communities in the US, where the primary sources of pollution are coming from transportation, as well as industrial, commercial, and residential buildings, with a little bit coming from wastewater and agriculture. Some of the big differences for this basin that are important to point out is that, one, this is a big number. So 110 million metric tons of carbon dioxide equivalent a year. And that's just, a factor of, this is a region that has a lot of land area and a lot of people. So obviously it contains the Philadelphia metro area, one of the biggest cities in the country. Total population of, I think, about 8.5 million people, and just a lot of activity and a lot of greenhouse gas pollution being generated. Communities in this region are a little bit more efficient, less polluting than the average US citizen per capita, but also much more polluting than the global average, which is only about 6.9 tons per person. excuse me. Another big difference in the inventory for this region, for this basin, that's worth pointing out and was, a big focus of our inquiry, is this portion here on the bottom of the graph, which reflects actually carbon dioxide removals from forest and farmland in the Delaware River Basin. And so particularly these forests are doing a lot of work every year, growing and drawing in carbon dioxide from the atmosphere. And they offset currently fully around 11% of the region's total emissions. And so that's really important. That's a great benefit to the planet and to the local communities. And we really wanted to understand, is there a way, are there options moving forward that removal, that offset could be enhanced or made bigger? And so there's a lot to work with in this basin when we think about land area. Over 1.78 million hectares of forest land, especially in the northern part of the basin. 0.62 million hectares of ag land, of farmland. We know that today it's offsetting around 11% of the region's annual emissions. But are there things that landowners and agencies and conservation groups, like some of the ones we have represented on the call, could be doing to help get more carbon removed through these areas? So yeah, let's get at that and let's break it down. We'll start with the forests, and then we'll think about the farmland and ask, could we do more with better management? So first, the forests. One thing to definitely point out here is just when you're thinking about carbon and natural areas, to try and separate carefully the idea of a carbon stock or a pool of carbon and a carbon flow or annual sequestration. And so in those 1.78 million hectares of forest, there is currently just a massive amount of carbon that is stored in trees, in vegetation, and then also in the soil underneath the ground. But compared to that massive pool of over 1 billion metric tons, there's a much smaller annual flow of carbon sequestration as you have, forests growing a little bit more each year and sequestering more carbon. And so it's that smaller circle that we're trying to figure out, are there things that could be done to increase that rate, that sequestration flow? This is a big challenge for forests in our region because the forests are actually quite mature. In many cases, it's been more than a century since there has been logging or harvesting on individual plots, and many of the forest stands in the region are a century or more in age. And why this is important is because as forests age, they grow more slowly and they sequester less carbon. So what I'm showing here is the result of a very detailed and intensive model that one of our collaborators, Alfonso, developed, where he actually, across this basin, looked at kind of pixel by pixel, forest stand by forest stand, the current age of the forest, and projected how sequestration would change over time, and then added that all up, projecting over the basin into the future. And what we found is that essentially the forests are becoming largely saturated in carbon. So the top line shows the total stock in forest carbon starting today and moving out to the end of the century. And you can see that it's very much leveling off. And the dashed line shows the annual flow or sequestration in those forests. And while that's quite a bit today, we expect it to really start to level off and trend towards zero by the end of the century. So without significant management changes, that 11% of removals that are happening from forests and farmland, we can expect that to really decline as the forests mature. So is there anything we can do about that? Well, one idea, actually somewhat counterintuitively, might be to increase the area of forests in our basin that gets harvested each year. And so, it might be a little bit counterintuitive to think that we could sequester more carbon by doing more logging. There's actually quite a bit of kind of research and investigation into this idea. And basically the concept is that younger forests grow faster and sequester more carbon. So here is a graph from the USDA Forest Service that kind of illustrates this idea. And on the panel on the left, you can see the total carbon stock in a hypothetical forest stand in the dashed line. And without timber harvests, you would expect that over the decades, as we just showed, that would kind of level off and kind of reach a stable state. But if you're logging that forest regularly, you're clearing a bunch of the wood out and allowing a faster growing forest to take place. And if those harvested wood products, which is illustrated on the panel to the right, are used for long-lived stable purposes, like building materials and wood furniture, and other things that are going to stick around and be long-lived, you're actually kind of banking the current carbon out in our houses and cities, and allowing new fast-growing forests to sequester even more carbon. So with logging, it's possible to have a net increase in carbon storage across the landscape. But a lot really depends on what you assume the forest products are being used for. If it's long-lived materials like building products and furniture, maybe a net benefit for the climate. But if it's very short-lived materials like paper products or stuff that gets landfilled, that completely changes the estimation. And so Alfonso, using the tool that he developed that I just described, actually took a careful look at this question and asked what would happen to forest carbon sequestration removals in the basin if we took current levels of logging and forestry, which are currently just a few thousand acres a year, and we either increase those substantially or we decrease those substantially. So what happens if we do a lot more logging? And he ran his model again, and we looked at the results and found that yes, you can get a small benefit in total carbon sequestration over the next century by increasing the area of forest that is harvested in the basin, but that it all depends on what you assume about, like I just described, what percent of the harvested material gets stored as long-lived stable wood products and what percent maybe goes to other uses. So just as to kind of benchmark our analysis, we looked at a value of 33% for harvested wood products that are long-lived. And that's a number that is kind of a regional benchmark that the U.S. Forest Service has published. And we compared that to kind of the high end, the best possible scenario of 100% of the wood products go to long-lived uses. And so if it's just a third that's in stable wood products, you can't make up for doing more harvesting, and carbon sequestration would actually decline if you did more harvesting, if you increase the harvested area by 20%. going from 1.97 million metric tons a year to just 1.85. But if we assume that all of the wood products are in stable uses, we can get a very slight bump by increasing the amount of area that's harvested. So I guess I can say this was a very detailed and lengthy elaboration to find that if we were to completely change how forests are harvested in the region, we could get a very slight improvement in carbon removals. So, in answer to our question, can we do more with better management? Yes, but it looks to be like it would be a very slight improvement around the edges. Another question to ask about forest harvesting is, the actual technique and approach to managing timber extraction in the region. Whether you're talking about a clear-cut approach or more ecological approaches where some trees are left as seed trees to provide propagals for regeneration, or a related approach of a shelter wood technique where you leave larger clumps of forest of trees to help with regeneration and maybe provide some other benefits during regrowth. We looked at this question using a model from the USDA Forest Service called the Forest Vegetation Simulator. And we found that yes, we found that the shelter wood and seed tree treatments do lead to a quicker and better kind of regeneration of forest carbon relative to clear cuts. So this is a simulation for a common forest type in the region that the USDA calls upland harvests, or which would be kind of a mix of oak and hickory. It's typically harvested on a 100-year rotation. And so in our simulation, we basically grew these harvest stands of forest for one rotation period, and then we established these different treatments to see how they compare during regeneration. And we found that the shelterwood seed tree approaches definitely led to quicker regrowth relative to a clear-cut approach. But we also found that in this case, not harvesting the forest would have kind of kept more carbon in the forest than either of these. And what that kind of speaks to is that quite often the rotational period, the economic rotation period that is often practiced on working forests, doesn't give fully enough time for the forest to mature and get to its maximum carbon sequestration. So oftentimes, if you're harvesting a forest on a faster kind of commercial regeneration cycle, even a more kind of regenerative approach with shelter wood or seed tree still has a carbon consequence relative to no harvest. Okay, so those are our results for the forested part of the landscape, which is a big part of the carbon story. But we also wanted to look at farmland and the possibility that with regenerative agriculture practices, farmers might be able to do more to get carbon stored in the soil. And so just for a quick primer on regenerative agriculture, it's a very exciting topic, an approach for farmers to be restoring and building soil in a way that not only helps their crops and the local ecosystem, but would also lead potentially to more carbon being stored in farm soils. And so farmers typically will apply a range of techniques under this umbrella of regenerative agriculture, which is really all about taking care of the soil and enhancing soil life with techniques like keeping the soil covered with cover crops, minimizing soil disturbance through techniques like no tillage or reduced tillage, integrating livestock into the farming system, and maximizing crop diversity with more involved rotations. So a quick primer on soil organic carbon sequestration and what you're trying to accomplish with regenerative agriculture. You're trying to, through the photosynthesis of your crops, draw carbon down into the soil where it can hopefully be stored for the long term. And you're also, as you're doing this, trying to manage the counteracting process of soil microbes respiring and breaking down that soil carbon. And so that's where it comes into play that techniques like minimizing tillage and incorporating perennials into crop rotations help to limit this respiration, this loss of soil carbon. Now, while this is all going on, of course, farmers are trying to fertilize and get an economic yield out of their crops. So they're adding nitrogen fertilizers, which can help to increase photosynthesis. But that also brings into play the possibility that some of those fertilizers are converted into nitrous oxide by soil bacteria and then lost to the atmosphere. And remember earlier, nitrous oxide is a very powerful greenhouse gas, some 264 times the global warming potential of carbon dioxide. So this is a lot to get a handle on, but we used a tool from the USDA called the Comet Farm Model to pull together a range of different regenerative ag practices on some Pennsylvania soil types and get a sense for how regenerative ag techniques would help with soil carbon and greenhouse gas emissions. We looked at a range of farming systems. So we looked at a forage crop rotation that might be typical on a dairy farm in eastern or southeastern PA. We looked at a cash grain system, and we looked at a perennial hay system. And so in the conventional comparison, this might be kind of business as usual. You have some pretty simple crop rotations that are involving intensive tillage and synthetic nitrogen fertilizers. And then as you move to regenerative systems, you're adding cover crops and more crops into the crop diversity, into the rotation, switching to no tillage techniques, and reducing fertilizer applications as you start to get some nitrogen from leguminous cover crops. And so you can feed all of this into the Comet Farm Model and get a sense for what the long-term, over a period of like 20 years, outcomes are for soil carbon as well as other greenhouse gas emissions. So here's a snapshot of our results on those questions. And these are some average numbers for, we looked at, I think, a total of 60 different locations across the Delaware River Basin for 6 of the most common soil types. And the yellow bars show the conventional rotations, the green bars show the regenerative systems. And you can see that, especially with the forage system, yes, you go from net losses of organic carbon, soil organic carbon each year, to net sequestration or removals in the regenerative system. The perennial system, to start out with, was already doing a lot of work as a carbon offset, carbon removal. And so we didn't really see much change with the regenerative system. It's hard to kind of improve on a perennial grassland system as far as soil management is concerned. So this is the carbon side of the question, but remember there's also the nitrous oxide side, which is the result of fertilizers being added and then converted often by soil microbes into nitrous oxide pollution. And here, actually, in some cases, we saw an increase in nitrous oxide pollution from the regenerative system. And that is kind of a counterintuitive result, but sometimes when you are adding a new crop, increasing crop diversity, you'll also be increasing points in the rotation where a farmer would have an economic reason to add fertilizer. And so that can overall change the balance of the total greenhouse gas budget of the farming system. And so definitely a really important nuance to keep in mind that when we think about regenerative farming and farming's role in climate mitigation, there's the carbon side, but the nitrogen and the fertilizer side is also really, really important. How does this all add up into the totals of the basin? So, we saw a little bit of benefit with regenerative soil systems. What would happen if this was practiced over the entire basin and over all farmland in the basins? If we really had, kind of a complete buy-in and adoption of these techniques by farmers. Well, we actually found that it probably wouldn't change the overall story of greenhouse gas emissions in the region all that much. So you would see a change and an improvement in removals. So those are the negative numbers. So you would go from ag being a slight positive to being a slight negative, but it's kind of a drop in the bucket compared to, again, that big total of 110 million metric tons per year coming from all of the houses, industries, and vehicles in the basin. I don't at all mean to convey here that soil and regenerative farming is not important. It's obviously incredibly vital for water quality, for biodiversity, for just continuing to produce food. But these numbers suggest it's a pretty small part of the overall climate mitigation story, at least for the Delaware River Basin. And here's just kind of another way of showing that. So we have a huge stock of soil carbon in existing farmland, but the total net that we can add each year with better management works out to be kind of a small portion. So I want to wrap up thinking just a little bit about land use alternatives and land use trajectories in the basin. I think if you kind of piece together what we've talked about so far, we have a story of a very large amount of climate pollution coming from this region. And we have, a significant portion that's offset by current forests and farmland, but not a whole lot of capacity to do more with better management. So you might walk away thinking that maybe forests and farmland, aren't the focus of climate action in the region. But I think that would be a mistake. And so with that, it's really important to think about the alternative land uses if forests and farmlands are not protected and are not carefully stewarded and conserved. And so this graph just shows emissions, removals, and avoided emissions from different land use transitions or kind of flipping from different land uses. Thinking about going from forest to development versus cropland to development, or forest to pasture, pasture continuing as pasture, forest continuing as forest, or even maybe some reforestation scenarios where pasture could be converted to forest. And you can see that every time that a forest or a cropland area is switched to development, there's a big swing from a removal to a positive source of emissions. And so this isn't just about the loss of biomass and soil carbon. It's also about the fact that as you go from forest to low density suburban development, which is the most common switch, and you would compare that to a counterfactual of in-building development within current settlements and towns and cities. Actually, households that are living in this environment, you see a big increase in their household emissions as they have larger homes, longer commutes, bigger heating expenses, just more greenhouse gas pollution. And we use some data from the American Farmland Trust that has looked kind of carefully at that flip from in-building, developing within existing cities and towns versus new low density development. And so that's where this big swing from forest to development comes from. It's that trade-off of not managing growth and the expansion of cities and towns. And so, from this, you can see really clearly that there is a huge importance to conserving cropland, farmland, and forests for the climate. But a lot of it has to do with that alternative scenario of losing those lands to rapid suburban growth and low density development. One other land use we just wanted to mention and that we looked at, and obviously this is a really kind of hot topic, controversial thing to think about, but if we're talking about climate change, we really need to put those numbers on the board. And that's the idea of using farmland for solar development. And when you think of the avoided emissions that an acre or hectare of utility scale solar can accomplish, that's really an appealing land use from a climate perspective. Leads to over 170 tons per hectare per year in avoided emissions, and isn't always necessarily in conflict with agricultural uses. So more and more we're hearing about systems of solar grazing and other mixed land uses that allow for solar production and food and fiber. Bringing that kind of all into context for the watershed as a whole, the Delaware River watershed community has kind of established this set of parcels across the basin called the opportunity parcels. And this is just kind of a set of places in the watershed that have identified as high value for conservation, both in terms of being larger blocks of land and for being, important for water quality in terms of being near streams or wetlands and other purposes. So given those numbers I just showed you, there's a tremendous kind of climate potential to whether and how those parcels are conserved and managed moving forward. If all of those parcels, and that's not to say this is going to happen or likely to happen, but just to kind of bracket it, if all of those parcels currently in cropland, pasture, or forest were lost to development, it would mean increasing the greenhouse gas budget of the region fully 20%. So potentially very large swing. And then alternatively, if we thought about using some of the, or all of the forest land in those plots for solar development, you could more than offset current emissions with renewable energy production. Again, not saying that's what's going to happen or what should happen, but it just gives you a sense for just in these high priority conservation areas, really how much the climate questions can swing one way or another, keeping in mind if or how successful groups are at conserving and protecting those land areas. So just to sum up, this is a very interesting and important watershed for the climate question. We have a lot of people, and it makes a big contribution to both the US and the global greenhouse gas budget. We found that forests currently remove or offset substantial amounts of greenhouse gas, and that we can increase the amount that forests and farmland remove, but really at the end of the day, very big management changes might make fairly small changes to carbon removals. And so that really highlights that land use planning and preservation of natural land are very much a key for climate action in the basin moving forward. And so with that, yeah, I really thank you for your attention and for joining us today. And I think I've been seeing some pretty healthy stuff coming in over the chat. And yeah, I think we have some time for questions and would love to get discussion going.
Yeah, we have about 15 minutes for questions. I think in the chat, we've been having some good back and forth. And I'm not sure if we see, let's see. So Kelly asked if there's a good resource to see the specific opportunity parcels, and I'll just point you to our colleagues at Drexel University and the Academy of Natural Sciences. Lynn Perez might be a good contact there. She's on the call today. We received the data set from them. I'm not sure if it's publicly available or if there's an online viewer available, but maybe she can chime in on the chat. Let's see. And then we have a question from Amy Hansen. There are several studies showing that old growth forests continue to sequester carbon as they get older, while younger trees take a while to grow and sequester carbon. Logging brings soil compaction from large equipment and erosion, stormwater runoff. Were these issues considered?
I can take a stab at that, Claire.
Yeah.
So thanks for the question, Amy. So the FVS models that our team ran, they extrapolate from kind of historical carbon performance in a number of surveyed parcels and then use that as inputs for the model. And I don't believe they include soil erosion, for example, or soil loss from operations. They also don't include the emissions associated with the logging, as Alfonso said. But they do show that there's initially a loss in carbon stocks as the kind of slash and down debris decomposes, and as now dead below ground wood decomposes and emits that stored carbon. And that after a while, the growth of the trees kind of outpaces the initial decomposition. So you get a leveling off of that curve and then kind of a net year-on-year removal after that. And they do show a slowdown in forest carbon removals with age, but not a total flatlining, but they do asymptote after kind of a certain number of years.
We also have a question from Larry Lloyd about the comparison of solar on commercial and even residential roofs compared to pasture conversions. I don't know. I know that's not something that we did in our analysis, but Franklin, I don't know if you want to take a stab at discussing that a little bit.
Yeah, great question. You know, you motivated me. I want to try and run these numbers after the call. I think that would kind of, yeah, it would tend to swing the per acre emissions of residential and commercial land uses in the right direction. I'm trying to remember a ways back, we had looked at this, some folks from Regional in Lancaster County are on the line. Leilani's on the line. There is a very significant part of the overall, you know, kind of electricity needs of, say, Lancaster, for instance, that can be provided by rooftop and on commercial and residential buildings, but not all of it. And so there's still, you know, I think a place and a need for farmland and utility grade solar as well.
Yeah, and Michael Bullard actually put a link into a recent publication about some some of the benefits of using bifacial panels on farmland. So that's in the chat for those of you interested in it. And I know there have been a lot of studies that sort of show or some studies that show the kind of boost in overall productivity when you kind of stack agriculture and solar together. So that's, I mean, so if done correctly, that can be potentially a good direction. I don't have any other questions in the chat, but folks are welcome to raise hands or unmute themselves if you want to ask additional questions.
I want to answer Amy's question in another way about the old growth forest growing. Is true. The old growth forests grow a smaller pace. Is never going to be zero, but also it depends on the dynamics, internal dynamics of the ecosystem. So if the forest is well suited with balance with the natural perturbations, you will have a growth because there is a internal renovation of the individuals. The problem is that we don't know exactly if the current forests are having this process. We don't know. Probably there are many forests that right now has problems with the renovation of new plants. Also, from the perspective of carbon sequestration, definitely rejuvenating the forest increased the takes. Other thing is that we had to balance if the amount, the characteristics of the harvesting. Effectively, we didn't consider the reduction of productivity based on the consequences of harvesting. We assume that the harvesting just is a takeout of the carbon. Is another point to consider, but how it's not measured the way the forest is affected by the productivity of forest is affected by the logging activities. But there should be a balance between how much wood we want to take out and increase our carbon sequestration between the benefits of diversity, erosion, and all those things that are threatened with the harvesting activity.
Thanks, Alfonso. Okay. Lori Yike asked if this is being shared with county and/or municipal officials to guide them in their land use planning decisions and ordinances. And I think from our perspective, we're getting the word out. We have not interfaced directly with counties or municipal officials, but I'm guessing that many of the folks on the call who are conservation practitioners do have partners or contacts in that realm. And so hopefully some of you all will be able to take this into those forums. I don't know if anybody wants to speak to that or not, anyone who's on the call.
one thing I could add to that, Claire, is we've shared this report, and I've talked with some folks at Penn State at their LCAP program, the Local Climate Action Program, which is administered by PADP. And some folks on the call might be familiar with that program, but it is a way that counties and townships in Pennsylvania can get started on local climate action planning, working with Penn State, and get some seed funding for writing a climate action plan. And yeah, I've been trying to share this information and connect the land use and land conservation piece into the LCAP process.
One suggestion I have is to present at the county planning association meetings that they have in the fall. The PSATs, PSABs, those trainings and conferences are held right here in, I'm sorry, I'm in Hershey, right here in Hershey. And I think it's always helpful for municipal officials who do not have the scientific background that you all have to understand what this means and how it affects them. I mean, really, bottom line is that we all know that local governments make land use decisions. They're the ones that are impacting really this a lot.
Yeah.
I mean, tremendously. And so, for example, one takeaway that I learned today that I didn't even think about was how mature forests aren't really doing as good of job on removing, for carbon as they are, the younger forests. I hadn't put that together for some odd reason. So is there an opportunity that, they could look at their land use and their forests and do some mitigation that way? And, the other thought I had too is obviously DCNR has parks and forestry land that we owned, and we're doing a climate plan, Claire, as you know. And so I wonder if this data is being utilized, if Greg Cernowski if he's taking this data. I would think that he's very, he's aware of all this work. So I think that's really important. And then, working with municipalities for so many years, it's always interesting to me that they tend to make action when there's a crisis.
Mm-hmm.
So they tend to, because they have so many other things that they're worrying about, and a lot. I'm just saying that we have to think about sometimes the regulatory requirements. The stick is often an incentive for the carrot. So when we, with all the MS4 permits coming about for renewal soon, and you talk about the CAP program, trying to figure out a way how our agency and other partners such as you all can take this data to other agencies like DEP and say, how can we integrate this into the plans? Because we often see that there's a disconnect between this science and the general public. And we have a wonderful opportunity here where, our Bureau can definitely help with this. I think can help with some of this messaging with our interactions with municipal staff and our connections and our partnerships. It's just, we need help on how to make that message, what is the talking points on that. And we also have tools through our grant program. We have comprehensive rec and open space plans. We have land management plans, and we've integrated some BMPs and green stormwater infrastructure messages and requirements in them, but they're not certainly to what could be a more impactful way we could help them.
Yeah.
So just some thoughts on that, Claire, that I've had for a long time.
Yeah, no, those are really good comments. And PSATs is certainly in Pennsylvania a potentially good forum. And I know that they've hosted speakers from Penn State before to talk about things like solar development and things like that. So so that might be worth a reach out to that group in particular. And we're happy to take other suggestions as well. We're about out of time, but I just wanted to highlight a couple of things in the chat. Abby from Open Space and from the Open Space Institute shared that they're hosting a webinar on February 27th about new forest carbon data and tools that are coming out this year. There's a LinkedIn post link there, as well as a link to the registration in the chat if you want to join in on that. Lynn Perez dropped in a link to the opportunity parcel data set as well. So that's available in the chat. And then I'll just close out with Larry Lloyd's comment about stormwater runoff from potentially coming from solar panels needs to be incorporated. And that's a very good point. These types of land use decisions always involve some kind of trade-off, and that's one of them. And I'll also say that I have some colleagues at the Center for Land Use and Sustainability working on a study that addresses that question right now. So we'll be releasing results from that study, hopefully this year at some point. I think we have another round of field work this summer, and then results coming out at the end of the year. So stay tuned for that. Franklin, any closing thoughts?
No, this has been a great discussion. Some really great points to consider. I think to Lori's comment, yeah, we would be very happy to talk and share this work with any agencies or local groups that want to learn more about it. And I think Claire has pointed out the link to the full report is in the chat there.
Yep.
And yeah, thanks for joining us today.
Great. Thanks, everyone. I'll be posting this up on the CLUS YouTube station, hopefully this afternoon at some point. We appreciate you joining us, and we'll see you all out in the field at some point soon, we hope. Thanks.